Hello everyone, welcome to my channel Love of Biology. Today we are going to learn about logistic growth. When the sources, that is resources, are limited, populations they will show this type of the growth. Population expansion decreases as resources become limited, leveling off. When the carrying capacity of the environment is reached, results in S-shaped curve. In the logistic population growth model, the per capita rate of increase declines as carrying capacity is reached. Okay, so per capita means per individual. The number of individuals of a particular species that environment can support, indicated by the letter K, which is called as the carrying capacity. Of a particular environment, the carrying capacity is maximum population size that it can support. The carrying capacity which will act as a force in growth rate by slowing it when resources become limited and stopping the growth once it has been reached. Population size increases and resources become more limited. Intraspecific competition will take place. So the logistic starts with a exponential model and adds an expression that reduces the per capita rate of increase as n approaches the k. N is the population size, k is the carrying capacity. So dn by dt is equals to r max n k minus n divided by the k. So dn here, that is actually the population size, and t is the time. Notice that when n is very small, that is k minus n by k becomes a k by k or 1. So the right side of the equation reduces to r max n, which means the population is growing exponential and is not influenced by the carrying capacity. On the other hand, when n is large, that is k minus n by k, come close to 0, which means that population growth will be slowed greatly or even stopped. The population growth is greatly slowed in the larger population with the carrying capacity. This model also allows for the negative population growth or the population decline. This occurs when the number of individuals in the population exceeds the carrying capacity, because the value of k minus n by k, that is the negative one. The logistic model of population growth produces a sigmoid curve. When we plot against time and the population size, when they reach the carrying capacity, they will show the S-shaped curve they will form. Okay, so in real population, exponential growth is possible only when infinite natural resources are available. This is not the case in the real world. Charles Darwin recognized this fact in his description of the struggle for existence, which states that individuals will compete for the limited resources. The successful ones will survive to pass on their own characters and traits to the next generation by natural selection. To model the reality of the limited resources, population ecologists developed the logistic growth model. So this was explained by the Charles Darwin in his description struggle for existence. Exponential growth may occur in environments where there are few individuals and plentiful resources, but when the number of individuals becomes large enough, resources will be depleted, slowing the growth rate. Usually, the growth rate will level off. The population size, which represents the maximum population size that a particular environment can support, that is the carrying capacity. Okay, so the growth rate will level off when they reach the carrying capacity. So the role of intraspecific competition, the logistic model assumes that every individual within a population will have equal access to the resources and thus an equal chance for the survival. For plants, the amount of the water, sunlight and many other important resources are present, they will grow. Whereas in the animals, the important resources are food, water, shelter, mates, nesting space, etc. Right? In the real world, the variation of phenotype among individuals within a population means that some individuals will be better adapted to their environment than the others based upon their resources. Intraspecific competition for resources may not be affect the population that are well below their carrying capacity. The resources are plentiful and all individuals can obtain what they need. However, a population size increases, the competition, of course, it will also increases. In addition, accumulation of waste products can reduce an environment's carrying capacity due to the competition. Okay. Okay, so next examples let us see. So yeast, which will show the S-shaped curve, it is a unicellular fungus. We know that when it grow in the test tube, it will show the S-shaped curve. Its growth levels of level offs as the population depletes the nutrients that are necessary for its growth. In the real world, is different. Sheep and harbor seals, in any example, the population size exceeds the carrying capacity for short periods of time and then falls below the carrying capacity afterwards. This fluctuation in the population size continues to occur as the population oscillates around its carrying capacity. Still, even this is the logistic model. It is confirmed due to these oscillations. Thank you for watching. Please subscribe my channel Love of Biology.